Hello guys, welcome back to the channel. Today we will be solving another Math AHL question relating to the Maclaurin series of different trigonometric functions. So for part A, we are asked to find the first two non-zero terms in the Maclaurin series for sine of x squared as well as sine squared of x squared. So for part 1 over here, we can approach this by first writing down the Maclaurin series for sine of x, which we already know. It's just x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus dot dot dot, as it is an infinite series. So what we can do is we can replace this x with x squared, which gives us sine of x squared is equal to, which is what we want, sine of x squared is equal to x squared minus x squared raised to the power of 3 over 3 factorial, which just gives us x squared minus x to the 6 over 6, as 3 factorial is just 6. For part 2, we need to find the first two non-zero terms for sine squared of x squared. So since we already know the Maclaurin series for x squared minus for sine of x squared, we can just square these two terms, or essentially expand them algebraically. So we just get sine squared of x squared is just this squared. So we're multiplying the series by itself. So if we expand it, we need the first two non-zero terms. So we just do x squared times x squared, which is x to the 4th. And then we multiply x squared times negative x to the 6 over 6, which is just negative x to the 8 over 6. And then we multiply this term over here by x squared, which just gives us negative x to the 8 over 6. And then after further simplifying it, our final answer for this part is just x to the 4 minus x to the 8 over 3. So for part B, we need to once again find the first two non-zero terms in the Maclaurin series for 4x times sine of x squared times cosine of x squared. So the main idea over here is to basically compute the first two non-zero terms in the Maclaurin series for cosine of x squared, and then multiply those two terms by the first two non-zero terms for sine of x squared, which we computed earlier, multiply that by 4x. So we already know that the Maclaurin series for cosine of x is just 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus dot dot dot. And so we can replace this x with x squared, which gives us the Maclaurin series for cosine of x squared, which is just 1 minus x squared raised to the power of 2 over 2 factorial plus dot dot dot, which is equal to 1 minus x to the 4 over 2, as 2 factorial is just 2. And now we can multiply this by Maclaurin series for sine of x squared times 4x. So we get the following expression over here. So if we expand this, what we can do is first multiply 4x times x squared times 1, which is 4x cubed. This is our first term. And then if we multiply 4x times x squared times negative x to the 4 over 2, that's just negative 2x to the 7. And then if we multiply 4x times negative x to the 6 over 6 times 1, that's just negative 4x to the 7 over 6. And then if we further simplify it, our final answer is just 4x cubed minus 8x to the 7 over 3. Thank you for watching.